Okay, so pages 9 and 10 are the actual midterm review proofs, which we actually started on the last page there, but now there's several more. So this one here just didn't give you any room to write the reasons, so I just wrote them to the side. WY is the angle bisector of XYZ. It's written up here. It's the givens. They're up there. So first one is given. So the first one is given. Now you got to be careful not to mix up the XWYs and the XYWs here. The next statement says the measure of XWY is congruent to ZWY, which is the top angle way up here. Those are congruent because of the first given statement, because the angle bisector in the first given divides an angle into two congruent angles. You don't always have to put all of your givens together. You can, and we usually do, but you don't have to. In this case, they said things that were related to the givens right after each given, and then when they were done, they went back to the next given and talked about whatever that affected after that. Regardless, the next statement, WY is going to be reflexive because that's in the middle. That is shared right here in the middle. And then here's the next given. XYW is congruent to ZYW. That's the angle at the bottom. That's another given. And then finally, it tells us asks us to prove the triangle is congruent. And we can do that by angle side angle. The bisector, the reflexive, and the other given angle. This is a fill-in-the-blank proof, which has popped up on midterms and regencies in the past. The first statement is just the givens that were written up above. ABC is isosceles, and BD is a median to AC. If BD is a median to AC, medians land in the middle, right? So that means it divides that segment into two congruent parts, just like a bisector would do, just like a midpoint would do. So that's actually the next statement. AD is congruent to CD because a median divides a segment into two congruent parts. A median will do that, a bisector will do that, a midpoint will do that. And since the third reason is reflexive, that must be BD is congruent to BD. Notice I'm marking my picture as I go. Now there's a missing statement here, so we had to throw in a 3A at the bottom here. AB is congruent to CB. And the reason that that's true, the slanted sides, is because it told us the triangle was isosceles up at the top there, and isosceles triangle have congruent sides. So now I have 3 congruences. So I can go ahead and prove the two triangles congruent, ABD and CBD, because of side, side, side. Now that the triangles are congruent, it wants me to prove a statement. This is as tricky as we got in our class. BD bisects angle ABC. So it wants us to prove that this angle at the top was bisected in half. And the only way we can do that is to prove that those two angles at the top there are congruent to each other. And we can do that by calling them angles 1 and 2, saying that they're congruent to each other because all corresponding parts of congruent triangles are congruent. Once those two angles are proven congruent, then you can go ahead and wrap it up with the prove statement, BD bisects angle ABC because angle 1 is congruent to angle 2. If those two angles are congruent, then the larger angle must have been bisected into two equal parts. So that's proving a statement. Number 3 on the next page. Again, not a whole lot of room, so we just write the answer to the side. This is set up much like the other one, number 1 on the first page. VT bisects RW. That is given. If RW is bisected, I'm going to mark it like that. And they went right ahead, and the next statement is what I had just marked, that RS is congruent to SW, and that's because a bisector divides a segment into two congruent parts. The next statement they put is measure of angle RSV, which is right there, is equal to the measure of angle TSW, which is right there. That's because vertical angles are congruent. They didn't call them 1 and 2, but I marked them that way so you can see them. Next, they go back to another given, that RW bisects VT, and if that's true, then those two sides are congruent right there. Which is TS and SV. So we have 1, 2, 3. The triangles are congruent because of side angle side. And the last one. I'm going to scribble on this one so you have to follow me and listen. The givens are right here. AC is perpendicular to BD, and that BD bisects angle ABC. But we're also going to mark that on the picture together. So there is the perpendicular, and if BD bisects angle ABC at the top, then those two angles are congruent. And that's what it says right here. Angle ABD and CBD are congruent because an angle bisector divides an angle into two congruent angles. Number 3, ADB and CDB are right angles. And that's because of this right here. Perpendicular lines form 90-degree angles. Now that we know that they're right angles, we can say that they're equal to each other. All right angles are congruent. Reflexive properties in the middle. BD is congruent to BD. I'll mark that on the picture too. Just based on the picture here, what do I have? Angle, side, angle. Angle, side, angle. And I'll call these triangles triangle ABD, and is congruent to triangle CBD because of angle, side, angle. And sometimes we write it like this in class. Either one is okay. And we're trying to prove that the triangle is isosceles. So one way you could do that is to prove that the base angles are congruent. So I'm going to say that angle A is congruent to angle C. And that's true up here because corresponding parts of congruent triangles are congruent. And now you can go ahead to your final prove statement, which is saying that the triangle is isosceles. The triangle is isosceles because an isosceles triangle has congruent base angles, which are A and C. The last video that will be posted tomorrow or shortly before the test is the mixed review on the final 2 pages.